This assignment is titled Patterns of Interaction. This video will be helpful for those of you who are absent from class in figuring out how to actually go about accomplishing what it is you're to accomplish. The assignment includes two attachments that you'll find. One with the reading, there's going to be 6 different scenarios, and then the second one contains 6 different graphs. Ultimately, what I'm looking for you to do is to match the graphs to the correct scenario. So you'll have to think about what's going on in the scenario and which graph is actually representing what's going on in a picture format. When looking at these 6 different graphs, you'll notice that the graphs either show you a population and an abiotic factor and what kind of happens as the abiotic factor goes up and down with the population, or you'll be looking at scenarios that include 2 different populations and what happens when one population goes up or down relative to the second. All right. So a sample that we'll do together would be, let's do scenario 2 here. Let's do scenario 2. And I'm looking at marine worms and ocean temperatures. This one's kind of nice because it just flat out tells me that I'm looking at a population of marine worms, and temperatures would be an abiotic factor. So now I know, just with that, and with some of these, like scenario 1, you will have to kind of read to figure out, are you looking at 2 different populations or one population and one abiotic factor? But once you have determined that, we can kind of narrow these graphs down to 3 possible options. Scenario 2, with the worms and the temperatures, population and abiotic, it could be graph A because that includes an abiotic factor in the population. It could not be graph B because that's 2 populations. It could be graph D because there's an abiotic in the population. Or it could be graph F. So looks like our options are A, D, or F. And I'm just going to take note of that really quickly. It will be one of those 3 graphs. One of those 3. So let's read a little bit, see what's going on. Looks like we have a scale worm that lives on sea stars and shallow ocean waters of the Pacific Northwestern. The population of worms looks like it goes up, so this goes up. And it does so when the water temperatures go down. So as this goes up, that goes down. And it looks like the population of worms would go down when the temperatures go up. So this is happening when this is happening, and this is happening when that is happening. Let's see if we can find a graph that shows that. And again, it can only be A, D, or F. Looking at graph A, let's start there since that's the first one. And let's see here. What do we see going on when our marine worms go up? Let's see, I see our marine worms, they go up right there, and right there. And again, when the worm population goes up, we should see the ocean temperatures going down. And during this time, it looks like the abiotic factor is in fact going down there. It's also going down there. And it's also going down there. So that's looking exactly what we're looking for. Let's check out the second part. When the worms go down, temperatures go up. Again, temperatures are abiotic. Here's our population, it's going down. And look, our abiotic factor is going up. So this definitely looks like our graph. Let's just run it really quickly past D and F first, just to make sure. D looks like going down, but it doesn't show anything about going up. So we can kind of rule out graph D as being a match for this one. Let's check out graph F. Graph F looks like going up and going up. We can rule out graph F, and we can definitely say that graph A matches up with scenario 2. So which scenario does graph A represent? It matches or represents scenario 2. Now how do we know that? Here's where we kind of have to justify our response. So we're kind of taking what we saw here and putting it in along with what we see here. So scenario 2, how do we know? Ocean temps or temperatures, they go down. And this causes, well, when the ocean temps go down, it looks like causes the populations to go up. Specifically the marine worm population. Cause the worm population to go up. And then secondly, we see that when ocean temperatures go up, looks like our populations are going down. And this graph definitely shows us that. We've now provided evidence of why this scenario fits this graph. You can use this as a sample, and now there are 5 left, graphs B, C, D, E, and F. 5 left. Of those that remain, I need you to complete 3 more and then turn this in. If you have any questions, please reach out.